Hello guys, welcome to our next video in the playlist Google Earth Engine for water resources. So in today's video, we're gonna look how we can detect the water bodies in a satellite imagery. So primarily we are using the normalized differential water index NDWI for short. So it's basically a satellite derived index used primarily to detect the water bodies in the remote sensing imagery. So there are mainly two versions of the NDWI. So one was founded in 1996, which was using the green band as well as the near infrared as a normalized difference in between them. So later it was much improvised, and we are using now the near infrared as well as short wave near infrared band for calculating the normalized difference with water index. So its applications are mainly in mapping for the lakes, rivers, or any kind of wetlands, or you can also monitor the drought with the use of it, and you can also go for detecting the flood conditions if there is an overflow of the river, and you can also separate the water bodies from the built up or the vegetation areas. So let's start. So for today's video, I'm taking the region of Mysore as my region of interest. So you just search Mysore in the Karnataka, and the map will zoom down to Mysore. So you just take this add a point tool and click at the center of the Mysore region. So why I'm selecting Mysore is because it has some number of lakes which we can identify through the satellite imagery. So you can just rename it as point if you want. So I want the administrative boundary for the Mysore region. So I'm going to search data called FAO, Global Administrative Unit layer. So here you will find much of FAO, GAUL, Global Administrative Unit layer datasets. So in which you have to take the second level administrative unit for 2015. So you will find three types. One is the country boundary, another one is the first level administrative boundaries, and second one is the second level administrative boundary. So these are the districts and these are the states, and it is a country boundary. So since I want Mysore, it's a district level administrative, so I'm importing the second level administrative boundary from FAO GAUL 2015 data catalog. So just rename it as FAO, and I'm creating one more variable called ROI, which is my region of interest. So from my FAO dataset, I'm filtering down with the help of the function filter bounds to my point. So just print this. You'll get a console. In the feature collection, you have one element. You just expand this features, and you will find a geometry collection. So where you can expand the properties to see the admin zero name is India. It is the country to which this second level administrative boundary belongs, and we have the admin one name Karnataka state, and the district name is Mysore. So we have got our region of interest. We just have to add this to our map. So with the help of function map dot add layer or ROI, click on the run. You can also center it around if you want. So with the help of function map dot center object, so every time if you click on the run, your map will be automatically zoomed into your region of interest. Yeah, we got the Mysore shapefile. So I want to have only the outline, so I want to style it. With the help of the function dot style, you open the dictionary and you specify the color to be black, so it is the outline color, and I want my fill color to be transparent, so use the hexacode. So this is an octocode for the transparent color, and you can rename it as region of interest for your layer and click on the run. Yeah, you just get the outline in the black color and the fill color is transparent, and you have renamed your layer name as ROI, which is region of interest. So now let's just go to our Sentinel-2. So import the Sentinel-2 surface reflectance sentinel-2 data and create a variable called a pre-image because I want to scale the sentinel-2 dataset. So filter it down with the help of function filter bounds to my region of interest and also filter to date. So I'm going for 2024 and 2025 so that I can get all the images from the year 2024. And I also want to filter my cloud cover with the help of function ee dot filter dot less than. So mention the property which you want to filter. So that is my cloudy pixel percentage. It should be less than 0.1%. So my filtering is done. Let's print the output to know how many image collections are available for this filter. So just print pre-image and click on the run. You had 29 elements for the year 2024 with the cloud percent less than 0.1 for the region of interest, our Mysuru. So here you will see the dates 2024, 12, 13, like that it's 12, 1. It starts from 1 January and it goes till December. So we have 28, 29 image collections with the less cloud cover of 0.1%. So let's just scale this. So I'm creating one more variable called image. So the scaling is done for the sentinel-2 datasets. So if you go to the bands, here you will find the scale value of 0.0001, which you have to multiply for each of the pixels in order to interpret it correctly. So this is my variable image. So for my pre-image, I want to map a function, create a function which will take input as an image, and it will return the image but multiplied by 0.0001. That's it. So take a median composite of it and clip to a region of interest. Now you just print this image. You'll get a single image with the scale values. Yeah, you have a single image with 26 bands. So it has been scaled now because the value ranges from 0 to 6.5. So now we need to calculate the normalized differential water index NDWI. So create a variable called NDWI and let's see, we need to have the normalized difference function. So this is the built-in function. You just go to the documentary and search normalized difference. In the image you have a function called normalized difference. So if you can just open it, here you will find the description of this function. So this function will compute the normalized difference between the two bands. So remember, in our case it is the near infrared as well as short wave infrared band, and here you will find the format in which it has to give. So the first minus second divided by first plus second, so that's called as a normalized difference. So what are all the inputs required? So here we'll find an image is required as an input, and you should also give the list of bands for which we have to calculate the normalized difference. So here you will see I have already given the image as the input. So now I have to give a list of bands to compute between the normalized difference. So before going there, we just let's look at the formula for normalized difference water index. So it's a index between near infrared as well as short wave near infrared. So I need to have a normalized difference between this in order to detect the water bodies. So let's go to sentinel dataset again to know what does the near infrared and short wave infrared contains, what is the band name. So come to bands. If you just scroll it down, here you will find B8 is my near infrared band with a 10 meter of spatial resolution, and we have two shortwave infrared bands with 20-meter resolutions, B11 and B12. So I'm going to use B11 or you can also use B12. So there will be just a difference in the wavelengths. That's it. So for detecting the water bodies, it will be useful if you get any of them. So I want to have the normalized difference between B8 and B11. That's it. My normalized difference is done. The NDWI is calculated. So you just print this to have it in the console and see if it has worked or not. So we have some internet issue. Yeah, we have a single image with the one band of ND. So it's normalized difference. So if you want, you can rename it as NDWI. So the use of function dot rename NDWI. Now click on the run. Yeah, now you will find the band name is renamed to NDWI with the values in the form of float. It means it's an decimal ranging from -1 to +1. So all the normalized difference numbers indexes will range from -1 to +1, and here we will find the data type as well as the CRS transformations, and the CRS is in EPST 4326. So that's the default CRS for Google Earth Engine. So let's just add this to map in order to know has it worked or no. So map.add layer, normalized differential water index. I want to have my palette. I want to have the minimum value to be -1 and maximum value to be +1, and I want my palette to be, let's say, uh, red for non-water bodies, and white for neutral values, and blue for the water bodies. So rename it as NDWI for the region of Mysore. Click on the run. So we have some internet issue. So let's just restart this adapter. So please make sure you have some better internet connection because it's running here. So we have some problem in the Wi-Fi. So just have to restart your adapter and you will get a new better connection. So yeah, now click on the run. We have two layers. One is our admin boundary and second one is our normalized difference water index stretched to 100%. So the value ranges from -0.2 to +0.2 and apply. Yeah. So you can also switch to satellite mode in order to cross check whether it has worked or no. So instead of red, you can have something like for ground color. You can also just adjusting the visualization. Yeah. So now if you can just zoom in, so you will find the water bodies wherever there you will get a blue color. So clearly it has worked. So you can just switch on and switch off. So in this part you can see all the water bodies has been detected. So the rivers are also detected. So this is the backwater of the KRS, which is a huge dam for Karnataka upon the Kaveri River, and it has also detected some of the river bodies in the blue color. So this is the upper Kaveri. So this is also one of the backwaters. So the numerous lakes, so everything is detected. So wherever you can find blue, so it's all water bodies. Yeah, so you can cross check with the background satellite imagery. So if you want, you can also enhance with the help of the palettes. So you can also export it with the use of the function export.image.to drive. So I hope guys you have understood how to calculate the normalized difference water index and how you can detect the water bodies with the help of Sentinel-2 for any of the region. So you just need to have two bands, near infrared and short wave infrared. So if you have any kind of queries, you can post it in the comment section. So thank you for watching.